So let's go through these and then we'll start our notes for today. Anyone find a mistake on number 1? So I'll say that for the most part these were solved correctly. The only thing that was wrong was that when they took the square root, it should have been plus or minus. So Emil made the mistake. So had they did the plus or minus because they took the square root, then it would have been fine. Even though they got this outside. Right. For all of the others, you can put those into Desmos. So I'm going to do that, show you how to do that. Aiden, Addison. So if I put that in, it'll give me my 2 solutions, and you would just write those down. So x equals, and then your curly brackets, negative 0.851 and 2.351. Okay. Then do the same thing for 3 and 4. So this one was 3 x squared minus 8x plus 1. You have 1 and 1.6 repeating. And then do the same thing for the last one. So negative 1.76 repeating and 2.26 repeating. Questions on any of these? So last class we talked about solving quadratics from square roots. Today we're going to be graphing quadratics. So if you don't have your calculator, you need that. Go grab that. So write what you see, write everything you see, attempt to rough sketch these. We'll talk about what those mean here in a second. So if you're on your phone, you should really be writing this down. And I'll start to scroll down here in a moment.
Did I say parabola?
Parabola. Anyone still need these first two things? Matt, make sure you're writing this down. Make sure you draw the rough sketches to the best of your ability. If you just want to make like a U shape, that works. U and then upside down U. Anyone still need the rough sketches?
Yes.
Okay. Anyone else still need the rough sketches? Make sure you're writing the things off to the side too. Who is still writing this up? So I'm going to go up to the beginning and talk through everything. one, we need to recognize that all of our equations are going to be written in this form. Should look somewhat familiar because when we were factoring the trinomials, it looked like the ax squared plus bx plus c. That was intentional. This is something you'll need to know, that it makes that U shape, which is called a parabola. You'll see that word a lot, especially moving forward into Algebra 2. Those of you going for that. As we are graphing them, there's a couple things that could help you determine which direction it's going to go. So if the number in front of x squared, your a, is positive, then it's going to face up. If it's negative, it's going to face down. That is important to remember. Then, here are some other things that are more Algebra 2 based, but we'll use them a little bit. The axis of symmetry. It's a line that basically splits your parabola in half. So basically, if you know what an x-intercept is on one side, it should mirror on the other side. Whatever this y value is, it should be the same on this value, and so on and so forth. So that should help you when graphing these. There is a formula, so I'm going to show you guys how to graph this algebraically and how to use your calculator to do so. But this is the formula. The formula you'll need for that. X equals negative b over 2a. When we get into our last lesson of this, that will look familiar. And then the vertex lies on your axis of symmetry. It's going to be the point that either goes down and then goes back up at that point, or goes up and then goes back down, either one. So we're going to talk about how to find our minimum and maximum on the calculator and how you could use that to help you graph. Questions on any of those things so far? I have like phlegm in my throat. It's gross. Alright. So we're going to do a few examples where we're drawing a rough sketch of these using the other pieces. So first we're going to find our axis of symmetry. We're going to do this algebraically and then in the calculator. So we're going to use our x equals negative b over 2a. So if you want to label, like here, we won't really need to label them, but moving forward when we get to our last lesson, you'll need to label them. So now would be good practice just to start doing that. Figure out which letters are which, A, B, and C. And then we're going to use B and A in our format. So we would have negative 8 over 2 times, what's our A value? Just 1. The A is just a number by itself. The x squared has nothing to do with that. So you would simplify this. And this would be the vertical line, so going back to when we were graphing, when we were writing equations, our Hoy-Bucks, this is a vertical line at negative 4 that will split our parabola in half. So we would write that here. X equals negative 4. Questions so far? To find the vertex, we need x and y. To find that y value algebraically, we would put this back into our equation and figure out what that is. So every time we see an x, we're going to put in negative 4. And then you can either do each piece and then combine them all at the end. You can put it on your calculator. I'm going to do it by hand, but you could put all of this in your calculator to figure out what that is. Be careful with your negatives and your squares. The square should go outside the parentheses, so this becomes positive 16 minus 32 plus 15. What would all of that be? I should probably have my calculator out too. What's 16 minus 32 plus 50? That's right. Is that what we don't have? Okay. So once you get that value, you're going to put those two numbers together. -4 and -1. So that would be the point on your axis of symmetry where it starts to go up or down. Say that one more time. Mm-hmm. Or should. I didn't do the math. Okay. Before we draw this sketch, is this going to face up or down? Based on your A value. Mm-hmm. Is this positive or negative? Positive, so it should face up. You could do that whenever. It doesn't really matter. So that means our vertex is going to be a minimum or a maximum. If A is positive, if A is facing up. Will it be the lowest point or the highest point? This, it'll be the lowest point. So what you could do is draw your X and Y axis. It doesn't have to be perfect, but if you want rulers, they're right there. We know it's going to face up. We know our vertex is at -4, so let's plot that. Draw a line. I would make it dotted like they did through that point. And then we don't know anything else about this except that's the vertex, that's the axis of symmetry, and it's going to go up. So just draw arrows up from there. These are rough sketches. That's your formula for your axis of symmetry. So negative, oh yeah, I did that so backwards. Okay, let's fix that. 1, 2, 3, 4, 1. My brain is not being circled. Okay. So if you did what I just did, you have to rewrite. I definitely messed that up. My bad. Thank you for catching that. It definitely should have been -4 left and down 1, and I did that opposite. Okay. Questions so far? Or other questions so far? On the next page, we're going to do another one algebraically, and then we'll change gears and do it on the calculator. So, yes, if you want to find whether it's going to face up or down, when you do that, doesn't matter. So if we want to do that first, is this A positive or negative? Negative, so is it going to face up or down?
No.
And this would be a maximum, correct. I didn't put minimum on the last one, but if you want to do that, you can do that. Alright, so let's find our axis of symmetry. I'm going to label my A, my B, and my C. And find my x equals -b over 2a. So I have negative 10 over 2 times negative 1. That would simplify to be negative 10 over negative 2. The negatives would cancel, and I'd have just 5. So my axis of symmetry would be x equals 5. Now let's take that 5, put it back into the equation to find our y value. So y equals negative, and then put your 5, plus 10 times 5 minus 23. And figure out what that is. I'm going to start to do this measure. So this would be negative 25 plus 50 minus 23. How is negative 25? The negative doesn't go with the 5, it goes outside. So the 5 is going to be squared, and then it'll be negative. So what would our vertex be?
5. For the, you have to put the negative outside the 5.
Here? Yes, because that's what our equation is. So whatever our equation has, we have to write. Alright, so let's draw a rough sketch. Draw your x and y axis. Plot your vertex first. Let me make sure I actually do this correct this time. So 5 to the right, up to. We know this is going to be a maximum. We know it's going to face down. You can draw in your axis of symmetry on that line where your vertex is. The reason it's dotted is because it's not really there. When you graph it, you won't actually be able to see it, but you'll be able to imagine where it is. And then from your vertex, you can draw arrows down. So once we know the basics and we practice algebraically on the calculator, then we'll see how to actually graph it and find all the points. What questions do we have so far? I would say yes, just because it'll help you see it split in half, and it'll really help you when we actually graph it. Alright, now let's do a couple examples, but on the calculator. Which ones did I want to do? 3 and 5. Okay, so we can still do this part. We'll come back and do these in a moment. So would this face up or down? Up, because it's positive. That's what this means. A is greater than 0, it's positive. A is less than 0, it's negative.
Yep.
No. I'm just writing it so it helps you. So that means our vertex is going to be a maximum or a minimum. The lowest point or the highest point? Lowest. Okay. There are 2 ways to do this on your calculator. You could do both. Sometimes you may need to do both. I've written those steps in red. You may or may not be able to see that from over there. But I'll do them with you. So for example 3, let's put that in our y equals. This would be your first step for any point, for any equation. So in y equals, type in 3x squared minus 12x plus 5. Remember, you can use the button by alpha for x. Some of you aren't typing this into your calculator. going to show you both ways, and then you can decide whether you want to do it by the graph, by the table, or algebraically. Once you have that in, go ahead and hit graph. If you can't see, so ours we can't, but if you cannot see it in the window, then the graph method will not work, and you'll have to use the table, unless you zoom out to find out. Okay? So we said that this is going to be a minimum. So we're going to go into second trace and find the minimum. And then it'll ask you for a left bound, right bound. We did that before with our x and y intercepts. If we know our vertex is going to be here, and we could probably count it, but it might be off. So just to make sure, pick something to the left of this. Doesn't matter what it is. So some point to the left. I'm going to choose 0 and hit enter. So I just typed in 0 and hit enter. And then some point to the right of your vertex. I could choose 5, 10, it doesn't matter. And then it'll want you to guess. You don't want to guess, you want it to do the work, so hit enter again. Now, the issue with doing it on the graph is sometimes your calculator will do this. This is really just 2. I don't know why it puts all those decimals. It's really just 2. How do you put 5 in there? I just typed 5 and hit enter. This is where your table would come into play. But from the graph, I can say my vertex is at 2, -7. I'm going to write that down. Which means our axis of symmetry is whatever the x value is. Now in Algebra 2, you will have to do the math. Here I'm giving you a choice. So we could draw the rough sketch from what we know already. We know it's going to be over 2, down 7. We know it's going to be a minimum and that it's going to face up. So it's going to look something like that. I'm going to go back to the calculator so I can show you the other method. So let's say you saw this was 2 point a bunch of zeros and you want to make sure that it's actually 2 and not 1.9 or something. You would hit second graph. And that point that we thought it was does say 2, -7. In the table, if you were just doing this and hadn't graphed it, you would be looking for where does it start to repeat. So let's say this table started at 0. You see the y value start to repeat. I see a 5, I see a 5, I see a -4, I see a -4. If I go up, I should probably see a 20. And you see that all the y values are repeating this way. So find the point in the middle. 2, -7. And that would help you find your vertex also. So whether you use the graph, the table, algebraically is up to you. You have to write down your vertex and how you found it. So you could show me your work algebraically. You could say you found it from the graph or table. You have to write down your vertex. How you find that is up to you. Questions on either of those methods? We'll do it again. just in case you miss anything. So let's skip 4, do 5, same method. We'll do table first instead of graph. Okay. So 4, 5, is this going to face up or down? Down, because A is negative. So will your vertex be a minimum or a maximum? Maximum, the highest point. Okay, so let's go ahead and type this in to y equals. So you can either clear out the whole thing and then retype, or you can just go over things and type over it. Mm-hmm.
So then,
So it'd be a negative, negative, and it would change to a positive. So I'll show you that in 1 second. We're still going to do it in the calculator, but if you're doing it algebraically, that would be negative b over 2a. And then the negatives will cancel. Right, so this time we're going to go to the table first, so second graph. I see that the y values are repeating. Where's the middle? Is there another y value with a 1? Or another x value with a 1?
negative 2 or 2.
So negative 2, 2 would be the middle. So anytime you see one y value, if you see another of the same, that's not the middle. So it has to be its own. So negative 2, 2 would be your vertex. So then our axis of symmetry would be what?
Going down. Oh, negative 2.
Negative 2. X equals negative 2. And then you can draw that rough sketch. We have a point at negative 2, positive 2 here. Ooh, that was not pretty. And then we know it's going down. So we'll look something. Before we get into the actual graphs, quick poll. Who likes the algebraic method? Okay. The graphing method, where you find the min or max on the graph. And then the table method. Okay. Alright. Of the remaining examples, look at 4 through 10 on this page. Which ones do we want to see? Go over, do. Okay. And which method do you want to use? Table, okay. So we're going to do number 8, table method. Is this going to face up or down? Down. Because A is negative. So that's going to be the maximum. Go ahead and put this into your calculator. I already forgot what that was.
How do you teach it in certain You're not teaching the graph, but the other.
The table?
Yeah.
Second graph. Negative x squared plus 4x. we're doing the table's second graph, I'm going to let you guys do it. Find where your y's repeat and find the middle. You may have to scroll down. What do we think? 2, 4. So the 3's repeat, the 0's repeat. If I scroll down, -5 and -12, and all those should also be. So 2, 4 is our vertex. There we go. So our axis of symmetry is what? X equals 2. So our vertex would be at over to the right 2, up 4. We know it's a maximum. We know it's going to face down. So we'll look. Oh, I forgot my axis of symmetry. Something like that. So for this problem, I would just say found in table. That would be my work. So we don't want magic math to appear. Show how you found it, either algebraically, in the graph, from the table. Any others from this page before we get into actual graphing examples? 10. Which method do you want to use? Okay. So this one we're going to do algebraically. Let's do the A first. Is this going to face up or down? Down. So this is negative. Which makes this a maximum. So then x equals, do we have a b? I should have labeled that first. What is it? It may be the second term, but that's not x. This is just c. So because it doesn't have an x, you don't have a b. So when you go to put in negative b, it's going to be -0. You don't have one. Over 2 times a. So what will our x value be? It would be 0. So if you don't have a b, your axis of symmetry is 0. So then if I put 0 in, what would my y value be? Eight. Because this would all become 0. 0 squared is 0 times 2 is 0. So that would just be 8. So our point would be 0, 8. Oh, got it. This would be 0. My bad. So then our point would be a y-intercept. And it would face down. Now, because our axis of symmetry is on the y-axis, I would use like a highlighter in that case to show that it's there, and then split the middle. other questions on this page?
Does it depend how wide you make the arrow?
Really we don't know anything else, so we're just drawing rough sketches. We're going to actually figure out how wide it's going to go here in a second. Alright, go on to the next page. So now we're going to actually find specific points. You'll have to graph at least 5 points. You can do more than that if your table or graph allows. So I'll show, we may not have time to get through everything I want to get through today, which is fine, because we were going to do 2 days of this anyway. But I'll do one algebraically. So our axis of symmetry, we don't have a B. We also don't have a, oh, sorry, it'd be A, not C. So our axis of symmetry is going to be what? 0, x equals 0. If I put 0 back in, what would my y value be? Also 0. So our vertex is going to be 0, 0. Whatever the vertex is, you're going to put it in the middle. Then you can either do this part algebraically or use your calculator. From your x values, you're going to go backwards and forwards. So -1, -2, 1, 2. Now, if you want to do this algebraically, go for it. I'm not going to do that if you don't have enough time for that. But you have to put each of these values in and figure out where your y value is. Or you could go to your table. So that's what we're going to do. So type in x squared. Go to your table, second graph. We already knew what our vertex was, but now we just need to fill in our y values. So we have x is -2, -1, 1, and 2. Put in those y values into your own table. So 4, 1, 1, 4. And really, once you know half of it, you should know the other half because it just repeats. So those will be the 5 points you're going to graph. Could you graph more than that? Sure. But we just need those 5. So we're going to start at 0, 0. We'll go -1, 1. -2, 4. 1, 1. And 2, 4. Once you have your 5 points, you can connect them. So I would say start at your vertex still. These you don't have to draw in your axis of symmetry, but if you would like to still see that it's there, you could. Before we talk about domain and range, do we have any questions about that? So, while you won't be tested on domain and range for these, it's good practice for our next unit where you will be tested on domain and range. We talked a bit about domain, but not in this sense when we were doing inequalities, when we were doing interval notation. So domain is all your x values. So if we're looking left to right, we have to imagine that this keeps going up and left, and this keeps going up and right. So for quadratics, for parabolas, the domain is always going to be all row numbers. So you can write that one of two ways. Either in set builder notation, which is these curly brackets, x, this line, x, this weird e, and this weird r. It looks weird. Or you can write it how we were doing it with inequalities, negative infinity to infinity. That means all real numbers. Every number imaginable will be there. Range, however, is always going to depend on, is it facing up or down? So it'll always go lowest to highest. So your lowest point, and I'm going to draw a line here just so you see where our lowest is at 0.
Yeah.
And then it keeps going up forever. So it's going to be everything, to infinity. So it's going to be everything greater than or equal to 0. So we write it like y is greater than or equal to 0, or start at 0 is closed, so it would be square bracket to infinity. Questions on either of those things? Let's do one more of these and then we'll be done for today. Let's do 3. So we'll find our axis of symmetry and vertex algebraically and then do the rest on the table. When we come back to this in 2 classes, I'll show you how to do all of this graphically or on the table. First, is this going to open up or down?
Down.
Down. I think I don't know if I did that for the last one. So our vertex is going to be a maximum or a minimum?
Oh,
Maximum. Just information to know. So if you know that stuff and you start graphing it the wrong way, that should tell you something's off. I missed something. Maybe I forgot to put in a negative. Okay, so let's do our x equals negative b over 2a. So we have a negative 8 over 2 times negative 1. Negative would become positive. I'm going to do this down here. But the denominator is still negative. So it would be negative 4. The order in which you do some of the stuff doesn't matter. So like if you wanted to draw in your axis of symmetry now, you can do that. And again, you don't have to draw it in. But now you know it's going to be somewhere around there. Your vertex is going to lie somewhere on there. So because we know our x value for the vertex, I started that. I put it in the middle of the table. I put it here. I'm going to find my y value now. So we put negative 4 into all of these things. Be careful with your negatives because it's negative x squared, so put the negative 4 in parentheses. We have negative 16 plus 32 minus 7.
So what positive 50?
Which one?
Negative. Yeah.
This. So this would become a positive, so a negative times a negative, but then it already has a negative, so it would still be negative. So that would be 16 minus 17, negative 1. Is that correct? Yes. Then we can fill in the rest of our x values. So go backwards and forwards. So backwards would be negative 5, negative 6. Forwards, negative 3, negative 2. Find everything else on your table. We're going to type this into y equals. Minus 3x minus 17. And go into the table. And we're looking for when x is negative 4. Very close. And fill in your missing values. So negative 5, negative 2, and then it repeats. And then you would graph all those points. So negative 4, negative 1, I'll start there. Negative 5, negative 2, negative 6, negative 5. What's nice about this is whether you do this from the table or whatever, once you have half of it, you should be able to do the other half. There's on the other side, this should mirror each other. Domain for this would be what? All real numbers, negative infinity to positive. Range now has been flipped because it's starting at negative infinity. I'm going to write it both ways. And the highest point is now at negative 1. So it would be everything below negative 1. Or negative infinity to negative 1 with a square bracket. Look for the lowest to highest. So lowest, it keeps going down, so it has to go to negative infinity. But it stops at negative 1. So it would be everything below it, so less than or equal to, or from negative infinity to 1. Got that we haven't talked about vertex form yet, and we're not doing that. So I'm going to move one of your Khan Academies to be due next week. The parabola intro, you should be able to do that one, but the graph, quadratics, and vertex form, I'm going to move till next week. Okay. So you can use this time to work on the ones that are due this week, the Khan Academies. Keep practicing in these notes. If you have questions, let me know. Make it pass.
And then Carolina, Kimberly just asked, so when she gets back. Mm-hmm. Make a pass.